Digital Differential Analyzer DDA. This is also line drawing algorithm which is actually used for drawing a straight line. Differential equation for this algorithm is dy by dx is equal to constant, which is or angle of y divided by angle of x, which is equal to y2 minus y1 divided by x2 minus x1, where x1 x2 and y1 y2 are the endpoints of the line. The solution of it is yi plus 1, which is equal to yi plus angle of y, and in the next stage yi plus 1, which is equal to yi plus y2 minus y1 divided by x2 minus x1 into angle of x, where yi, which is the initial value for given steps along the line. This DDA is actually used to draw a straight line rapidly by maintaining the brightness and orientation of the straight line. Also, it is not possible to draw a line directly because we have to find out the slope of the line, so that we need this differential equations and also solution of it. So it is the actual algorithm of a DDA where two endpoints of the line are considered as x1 y1 and x2 and y2, which is not equal, so that we are taking the example for the same, where x1 y1 it is considered as the endpoint 0 0, and x2 y2 we are considering endpoint that is 5 5. So whenever we are using this algorithm, suppose we are having the integer values which is like minus 8.5, we need to consider it is as a minus 9, not a minus 8. So in returns we are getting values minus 1 0 and 1 for less than 0, equal to 0, or greater than 1 respectively for the approximate line length. We need to calculate here absolute point or slope of the lines by using x2 minus x1, which is greater than or equal to ABS of y2 minus y1. Then we are getting the actual length, which is equal to ABS x2 minus x1, else we are getting the actual length by using ABS is equal to ABS y2 minus y1. So we are considering this example, that is we are having two endpoints, that is x1 y1 x2 y2. As per that, for the length, we need to find out the length, we need to calculate these values, that x2 minus x1 we are getting 5 minus 0 is equal to 5, where x2 containing the value 5 and x1 containing the value 0. So after making the calculation part, we are getting the length is equal to 5. Else suppose we are getting the ABS of y2 minus y1, where y2 is again having value 5 and y1 is having value 0. So after making the subtraction, we are getting the value 5, means we are getting the actual length of the line, it is length 5. Then next is selecting the larger of angle of x or angle of y to be one raster unit. Here for the angle of x, which is equal to x2 minus x1 divided by length, means as we get the answer of x2 minus x1, that is 5, divided by length 5, we are getting the answer for the angle of x, that is 1, that is 5 divided by 5, and angle of y we are again getting y2 minus y1, that is the value 5, and the length we are having, that is 5. So that after dividing the both the terms, we are getting the value again 1. So whenever we need to move to the next phase, that is x is equal to x1 plus 0.5, means we are adding the values, where x is equal to x1, our x1 is nothing but a 0, and plus 0.5 means we are getting the value x is 0.5, and for the y we are getting y1 plus 0.5 means 0 plus 0.5, that is y is equal to 0.5. So that we are getting these values here, which is we are making the beginning of the main loop, where I is equal to length, means I is equal to 5 in our case. we are applying here a while loop where while I is less than or equal to length, means I is less than or equal to 5, then setting the pixel value, that is integer x and y. So for the x we are getting x is equal to x plus angle of x, means x is equal to 0.5 plus 1, which is equal to 1.5, and for the y again 0.5 plus 1, which is equal to 1.5. we are maintaining this loop up to the level 4, 4, means up to fourth stage or fourth level of increment. Up to 4 increments we are making in the loop, so that at the last we are getting x is equal to 5.5 and y is equal to 5.5, and the line is drawn, means we are actually maintaining the line length by applying this algorithm, and we are drawing the line rapidly by using DDA line drawing algorithm.